In this video, I will show you how to take a graphed triangle like this and prove whether it is scalene, isosceles, or equilateral. I will also show you how to prove whether or not it is a right triangle. Okay, so first of all, you need to understand that an equilateral triangle has three congruent sides. Three congruent sides. All right, three sides, equal length. An isosceles triangle is going to have two congruent sides. And a scalene triangle has no congruent sides. So, if I want to know how many of these sides are congruent, I'm going to need to calculate their length somehow. So what I recommend is the Pythagorean Theorem. So we're going to calculate the length of side AB. We're going to calculate the length of side BC. And we are going to calculate the length of side AC. Alright, and I'm using these colors so you can follow the source of the calculations. So, what I recommend is draw a right triangle that has AB as the hypotenuse. So this is going to be a very narrow triangle because to get from A to B, I'm going to go over 1 and then down however many this is. Okay, so I have a horizontal width of 1, and vertically that's 7. 1 and 7. But this is a right triangle. AB is the hypotenuse. So I can use the Pythagorean Theorem. So c squared is equal to a squared plus b squared. So 1 squared plus 7 squared. So then, if I want to get c by itself, I would take the square root of both sides. And so that'll give me the length of AB. Okay, so what is that going to be? Okay, so that is 5 radical 2. In fact, you know what, let me just show it by hand. So 1 squared is 1, 7 squared is 49. So this is going to give me the square root of 50. So that is approximately 7.1. So the length of AB is about 7.1 because that's the square root of 50. So let's go ahead and do the same thing for BC. So again, I'm going to draw myself a right triangle that has BC as the hypotenuse. So the vertical portion is 2. The horizontal side is 6. Okay, so here again, c squared is equal to a squared plus b squared. So if I take the square root of both sides, that's going to give me c is equal to the square root, and here I have 36 and 4. So c is equal to the square root of 40. Okay, so that's 6.3. Okay, and finally, AC. So again, we will make a right triangle that has AC for a hypotenuse. So I see a vertical change of 5 and a horizontal change of also 5. So in this case, c squared is going to equal, whoops, it's not time for the square root just yet. Jumping the gun, as they say. C squared is equal to a squared plus b squared. So that means c is going to be the square root of all of this. So c is going to equal the square root of 25 plus 25. So c is equal to the square root of 50, which is the same thing I got for AB. So I already know that that is 7.1. So, considering the fact that I just discovered that there are two congruent sides, okay, AB and AC, that means that this is an isosceles triangle with two congruent sides. So I showed my calculations with clear and easy to follow calculations. So now I can go ahead and say isosceles. For problem number 13, I need to prove whether or not this triangle is a right triangle. So I'm going to use slopes to do that. So let me explain one thing about perpendicular lines. If I have two lines that are perpendicular, alright, perpendicular means that they form a 90-degree angle. Let's say that the slope of one line is 2/3. Then the slope of a perpendicular line will have two qualities. Number one, it will be opposite in sign, and number two, it will be reciprocal. Opposite and reciprocal. That's how you describe the slopes of perpendicular lines. So the slope of this other line, this perpendicular line, will be reciprocal. So instead of 2/3, it would be 3/2. And it will be opposite, meaning instead of positive, this one will be negative. So I can use that property to figure out if this is a right triangle, because if this is a right triangle, that means that one of these angles has got to be a right angle, like this. And if there's a right angle, that means that two of these sides have to be perpendicular. And if I know the slopes, I will recognize that they are perpendicular because the slopes will be opposite and reciprocal. So if I find all the slopes, and then I look for a pair of them that are like this, opposite and reciprocal. If I see this pattern, I'll know that they are perpendicular, which means there's a 90-degree angle, which means it is a right triangle. If none of the slopes are opposite and reciprocal, then it's not a right triangle. So that's my thought process. That's my theory, that's my strategy. But it all starts with finding the slopes of everything. So let's do that. So let's find the slope. Okay, I'm going to use M for slope. So let's find the slope of segment AB. And then we're going to find the slope of segment BC. And then we're going to find the slope of segment AC. Okay, let's do it. Let's start with AB. If I go from A to B, the slope is going to be the rise over the run. Okay, so that rise is positive 3. All right, I went up 3, so that's my rise. And I went over 5, 9. I went over 9. Okay, now 3 goes into 9 evenly, so this is going to reduce down to 1/3. So this is the slope of segment AB. I always like to double check that I have the correct sign. I have this as positive 1/3, and I notice that segment AB from left to right is going uphill, so it should be positive, so that sounds good. Alright, now let's move on. I'm going to erase this, get it out of my way. Now let's talk about the slope of BC. Alright, so if I want to go from B to C, or from C to B, either way, I need to think about the rise and the run. Okay, so look, I could draw it outside of the triangle like this if I wanted to. But in this case, I'm not going to do that. I could, there's nothing wrong with that, but we're so comfortable saying rise over run, that I like to draw the rise first and then the run, just so I do it in the order, so I don't accidentally write it backwards. So as I go from C to B, first I'm going to do the rise, okay, which is that. And how many is that? So that's 4 and then 5. So that's going to be 9. So I did a rise of 9. Okay, now I'm doing a run of whatever that is. So that's 3 and 4. So that's 7. So I did a rise of 9 and a run of 7. Okay, and that doesn't reduce. So I just have 9 over 7. Okay, and from left to right, this is rising. So it makes sense that this is a positive 9 over 7. Okay, let's keep going. All right, so far these are not opposite or reciprocal. Okay, so our last hope for having a right triangle is AC. So if I made a right triangle, well, if I want to do the rise and run of AC, so the rise, I'm going down for the rise, so that is -6, and then the run, I'm going right to, so that's a +2. So rise over run, that is -6 over +2. Now that's going to reduce down to -3. Okay, now the question is, are any of these opposite and reciprocal? Well, obviously, nothing is opposite, well, nothing is the reciprocal of 9 over 7. All right, the reciprocal of 9 over 7 would be 7 over 9. None of these are 7 over 9. However, what about these? What about these right here? Okay, the reciprocal of 1/3 would be 3 over 1. And that's really what this is, right? 3 is the same thing as 3 over 1. So these, these are reciprocals of each other. Also, one is positive and one's negative. So they're also opposite from each other. So these are opposite and reciprocal. That means that these lines are perpendicular. Okay, so that tells me that AB and AC are in fact perpendicular. So that means I have a 90-degree angle right there, which makes triangle ABC a right triangle. So using clear and easy to follow calculations, I have now proven that this is a right triangle. Just for good measure, I'll mention opposite and reciprocal. Okay, as part of my proof. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.